So in previous classes we have discussed all the question from 2024. Now today we discuss some question from in other year like 2023 we see. So you see now you will get a common question. Okay, so this is your 2023. Okay, from here it is starting. Okay, so find a characteristic equation and eigenvalue of the system. So you know what you have to do, right? So I just guide you. You just make sure that you are getting the same answer. You find the determinant of that, and I am writing its direct polynomial. Okay, the polynomial you will get from here, it will be minus lambda cube plus 6 lambda square minus 8 lambda equal to 0, or you can multiply with that, so you have this thing. Okay, so this is your polynomial, and what are the eigenvalue? If you factorize this thing, you will get lambda into lambda minus 2 into lambda minus 4, so lambda equal to 0.24. So you see how easy this one. Okay, that's it. This you have to do. Next question, you see here that type of property is satisfying not. What are the sum of the eigenvalue? It is 6. You see what is the trace of the matrix? That is also 6. Yesterday we have discussed. And what is the product? Product is 0. You will see the determinant will be also 0. Okay, because also we have discussed that here basically if you have some constant term, that is basically the determinant thing, right? So here the constant term is not there, that means determinant will be 0. Okay, so from there you can say it has a eigenvalue 0. Okay, so I am going to next question. So that is this one. So this is also common, right? Yesterday we have discussed this type of problem. Okay, so if you have any doubt here, you just let me know in WhatsApp. Okay, but you practice yourself. So here basically first you have to consider the augmented matrix, right? So what are the augmented matrix? You have to find the value of A and B, right? How many unknown is there? Yeah, A and B. Condition for which? So basically you have to find the condition so that you have this type of thing. So what are the augmented matrix? 1 2 1, 2 1 3, 1 A 3, and 1 B B plus 1. Okay, now do some operation. Okay, now if you do operation like first you try to make this one 0, so R3 minus R3 dash is equal to R3 minus R1. Okay, after that suppose you are doing R2 dash is equal to R2 minus 2 R1. This type of operation you do. I'm writing that directly because you know how to solve this type of problem. Okay, so 0 minus 3 1 B minus 2 0 A minus 2 2 and then B. So you have this type of thing. Okay, now you have this type of thing. Now you just see the last one. Okay, this will guide you what are the solution. So first thing, what is the determinant of your normal matrix A? That is basically 1 2 1 2 1 3 1 A 3. It would be better if you find at the first line. Okay, anyway, so I think 3 minus 3a minus 2 into 6 minus 3 plus 1 into 2a minus 1. So what you are getting, 3 minus 3a, that means you have minus a, right? And from there you have, that is, here you are getting 3 minus 6 minus 3 minus 1. So I think I am doing the row operation first. It is a little bit lengthy. So first find the determinant. Why? Because you know, whenever you have the full rank, then you have unique solution, right? So this condition you find first. So first find the determinant of a. So basically you are getting minus a minus 4, right? So minus a minus 4, yeah, minus a minus 4. So basically determinant of a not equal to 0 for a not equal to minus 4, right? So then only solution. So only solution condition is this one. Okay, now for a equal to 4. Okay, so for a equal to 4 you are finding the row operation. So now you can substitute the value of a, right? So just put a here. So after that step is equal to minus 4. So if you substitute this, so basically you are getting minus 6 here, right? This type of step. Now basically we have to focus on the last row, right? So we'll do one more operation, like r3 dash equal to r3 plus 2 into r2 minus. So what you have, zero. So you have minus 6 plus 6, right? So 0, and then 2 minus 2, right? So this is also 0. And what you have here, b minus of 2 into b minus 2, right? Basically minus b plus 4. So you have this thing. So what do you expect from here? If your this element is 0, then you have infinite solution, but this is not equal to 0, then no solution, right? So basically from there you are getting, if minus b plus 4 is 0, then b equal to 4, right? Then infinitely many solution. Many solution. Okay, and if your if b not equal to minus 4, then no solution. I think from onwards you can solve any of the this type of problem. Okay, so yeah, I am deleting this part, I think. Okay, 2020, this is, I can delete. Next, state Cayley-Hamilton theorem. So this type of state Cayley-Hamilton we have already written. Now find, using the theorem, find A inverse. Okay, so this problem also we have done, I think, for 2 cross 2 matrix, right? So I just write the corresponding. First find a characteristic equation. This is you have to find. Now after that step you have to find a let me write the characteristic equation. Characteristic equation. A characteristic equation, suppose you are getting like, I'm not sure, I just write the equation. So lambda q plus lambda square minus 7 lambda minus 1 is equal to 0. Okay, so using Cayley-Hamilton theorem, so first statement you can write, okay, state, this is your first part, you have second part, this one, maybe this type of problem 2 plus 4, so 2 marks is here, 4 marks for the remaining part. Hamilton theorem. So you have aq minus plus a square minus 7a minus I, don't write 1 here. So after that what you will do, you take a common from the first three. So what you have, a square plus a minus 7i, this you can write as I here. So what you can say from here, so a into a inverse is always I, right? If there is some constant, you will divide by that number here, that we have discussed in the class. So what you expect from here, so a inverse would be this element, right? So a square plus a minus 7i. So that's it. Now you just substitute the value, find the a square first, okay, then substitute here, you will get the a inverse. Okay, that's it. Next one, now to the this part that I think we have not discussed yet. So for the congruence type, what you have to do, whatever operation you are finding, you have to do the same for the column also. Okay, so for example, you have to check this is congruence or not. Okay, so first we will try from the A. Okay, A matrix, that is your this one, that minus 2, sorry, 2 minus 2 0 minus 2 1 minus 2 0 minus 2 0. Okay, now from there you have to use some operation. So what operation you expect to for equivalent type of form? First you have to do this thing 0, right? So you have to do basically r2 dash will be r2 plus r1, that you expect. So this if you have to do, so same thing you have to do for the column also. So I just write that line. Okay, then 0 minus 1 minus 2, 0 minus 2 0. Okay, so then you have to do actually same operation for the column, c2 plus c1. So whatever you are getting, just write this. So 2 1 0 0 minus 1 minus 2 0 minus 2 0. Okay, so you got this type of thing. Now what you expect, you have to remove this term, right? So you just use the operation, what, r3 dash will be your r3 plus you can say 2 r2, right? So same thing you have to apply for the column also. So first find what you are getting. Okay, so basically 2 1 0 0 minus 1 minus 2, then you have 0, then you have 0, then you have what you are getting, 0 minus 4. If there is any mistake, you just check. Okay, so similarly you have C3 dash is equal to C3 plus 2 C2. You have to do 2 0 0 1 minus 1 0. C3 will C3 plus 2 C2, so 2 here, I think I am making some mistake. This is not plus, this should be minus, right? Otherwise how it cancel? So 0 minus of that, so it will be plus 4. Okay, now C3 minus 2 C2. Okay, so many mistake is there. C2 dash is equal to C2 plus C1, so C2 plus C1 whenever you are doing, this is also 0. Okay, this is also 0. So you are getting this type of thing. Okay, so in the diagonal what you are getting, 2 minus 1 4. Okay, okay, so whatever you got, you have to do the same for your column also. Okay, so basically here you can make this type of thing, 1 minus 1, this type of combination. Okay, like this will be equivalent to your 2 plus 1 minus. Okay, so for example, if you do r1 dash is equal to r1 by root 2 and c1 dash will be c1 by root 2. So basically then this element will be 1. Okay, 1 0 0 0 minus 1 0 0 0 4, that you got. Next, I am making it totally normal form. Okay, so after that you see you have to swipe, right? R1 and R2 and C1 and R2 and R3 and C3 and C2 if you change, so you will see 1 0 0 0 0 4 0 minus 1 0. After that this will be again changed, C1 C2, so you will get 4 here basically, and this 0 minus 1 here. Okay, now after that what you have to do, R2 dash will be R2 by 2 and C2 dash will be C2 by 2. Why I am dividing by root over of that? Because you have to apply the same operation, right? So that's why you are getting 1 1 minus 1 0 0 0 0 0 0. So this is of the form diagonal 1 1 minus 1. Okay, now you have to do the same job for the B matrix. Okay, now you just apply. Okay, so you just do this type of problem similarly. I think after so you will get similar type of thing. Okay, if it is 1 positive 2 negative, then we will say this is not thing. Okay, but practice similar way. Okay, here also you will get 1 1 minus 1. Okay, so then we can say A and B are congruent. So what you have to do, whatever operation you are making, you have to apply the same for column. Okay, then you practice this problem. Okay, this is your port 1. 51 is what? 51 is your, for the matrix PAQ will be full reduced normal form. Okay, so here basically that PAQ, this type of problem, you have to do the same thing, full reduced normal form. So reduced normal form, basically you have to do that I2 type of form, right? That something is 0. Okay, let's write in fresh page. Okay, so what you have, 1 0 1 2 1 3 minus 1 1 2. Okay, so then apply this type of transformation. R2 dash will be R2 minus 2 R1, R3 dash will be R3 plus R1. Okay, so using that you will get this type of matrix 1 0 0 0 1 1 1 1 3. Okay, now after that step you apply this element 0, so R3 dash will be R3 minus R2, now after that step you just make this 1. In the congruence, basically you have to do that row and column together, but here in the normal form you don't have to do that. Okay, basically first you apply all the row, then we apply the column to get that type of form in this way. So R3 dash will be R3 by 2 if you do so, and we can do one more operation, right? That just so you will get, you see, almost total identity matrix. So you got this, so you don't have to use any column operation here. If you have to do so, then basically you need and that Q matrix. Okay, so how you will write this type of how many operation you have used here, so that type of operation you have to apply one by one. Okay, so basically if you see the first operation you have used here, so P you can write as, so last operation is this one. So basically what is this matrix? E2 3 minus 1, right? Then you have E1 3 minus 1, then you have E3 of half, right? Then you have so this 3 operation is done. Now you have the previous operation, what that into E3 2 minus 1, then you have E3 1 1, then you have E2 1 minus 2. Okay, so these 3 operation you have. Now you have to do some matrix multiplication. Okay, so first you have to multiplication this and this, then this and this, then this and this, then you multiply, and overall you get some matrix. Okay, so this is little bit lengthy problem, and after that you will get Q will be I3 because you don't have to do any column operation, right? Suppose instead of that, suppose you have some 1 here, okay, or some element of which you are, or suppose this is 2. So in that type of problem you may need that Q operation. Okay, anyway, so Q is for the column. So in this way you have to do this one. Next one, you see this is common, this 6th one is totally common. Okay, this okay, 6 is common. 7, find RREF, you can do easily. Okay, find a rank. Okay, this is common. Find a full reduced normal form, already we have seen how to normal form, full reduced normal form you have to do. Okay, so here basically you have to do the column and row, then you have to column. Okay, then and here you have to find the eigenvalue, eigenvector, so you can do this type of problem. Okay, next, this one is very tricky. So basically whenever you learn the polynomial, read the first problem. Okay, so basically alpha beta gamma is a root of this equation. Okay, so that sum of the roots which your the next order, that is x square coefficient is 0 here, right? So you have basically alpha plus beta plus gamma is 0. Okay, so here if you do that just one operation, so you will get if you do R3 is equal to R1 plus R2 plus R3. Okay, so you will get that alpha beta gamma alpha 0 0 0, right? So then you have this is rank 2, that is very easy. Okay, yeah, but here also you have to say that obviously this is also not 0, alpha beta and beta gamma. Okay, so for this one what you have to do, you see they are given that their roots are in AP. This type of problem I think you have done in your class 12 level also. Okay, so whenever you have the root are in AP, so you have to think that if your one root is your beta, so other root like beta minus d, beta and beta plus d, yeah, these are the 3 root. So you can think this is your alpha and this is your gamma, right? So from there you just find alpha gamma minus beta square, that is this minor. Okay, this minor is non-zero if you show, then this rank is 2, right? So basically what you have, why right, so already we have seen it has a 1 row 0, so its rank will be 2 or its lesser. So now you have to think that its rank is exactly 2. So let your beta is your let alpha is equal to beta minus d and gamma is equal to beta plus d. Why I am considering? Because they are in FE for d greater than 0. Now you just think the second minor, right? Second to consider 2 cross 2 minor, alpha gamma minus beta square. So what you have, beta minus d into beta plus d into minus beta square. So from there you will get you see minus d square, right, which is a non-zero quantity. Sorry, so you have that is non-zero. So from there you are getting basically beta gamma, yeah. So from there you are getting, so rank is 2. Okay, this is done. This type of problem already we have solved so many times. Okay, this type of problem where we have to find A. Okay, find a inverse. So A inverse already you have seen. Okay, now there is a one this type of problem, A to the power 9. So how you will apply? Okay, I think where we have complete this type of problem. Yeah, so you see you have AQ is equal to this type of expression, right? Now if you apply this AQ, okay, so basically if you write AQ here at this side, okay, and the remaining part on the other side, so minus a square plus 7a minus I, okay. Then suppose you are multiplying with a q already you have find. Now if you find a plus b wholes plus c whole to the power 3 formula will be little bit, I think, lengthy. You have to find suppose any power. Okay, so suppose a to the power 4, what you will get? Minus aq plus 7a square minus a, right? Again in this expression you can substitute the value of this previous one, so minus of minus a square plus 7a minus I plus 7a square, okay, minus a. So you are getting this a to the power 4 expression, okay, something like that. Okay, now suppose after that you have to find a to the power 5. Again you have to multiply a, or suppose if you multiply these two expression aq and a4, you will get directly a to the power 7, right? So in this way you have to simplify your equation. Remember, whenever you will find, you don't have to find more than 2 power. Basically maximum you have to find the a square, otherwise because you see here we have find a to the power 4, but all the expression in terms of a, I and a square, right? So similarly if you do the a to the power 7, so what you have to do? A q into a4, whatever you are whatever you are getting after that expression, you substitute the value of aq in this form. Whenever you will get aq, you substitute in this form. So in this way you have to find all the higher order power. Okay, that's it, I think. Yeah, this is we have find. Okay, there is some question from linear attachment that are out of the syllabus. Okay, okay, I think we have completed this type of problem. Now this rank index signature only we discuss. Okay, that basically you have to complete in the normal form. Okay, then that is that 1 1 minus 1, that type of problem you have to do. Then you have to find what is the rank index signature, this thing. So basically here you have this matrix. So if you apply this type of operation, suppose you have starting from here, you do some row operation, same you have to do for the column operation. Okay, in this way if you complete this thing, you will get this type of thing. So from there you will say, yeah, the your index is 2, right, and signature will be 1, and rank is your full, right, the 3. That's it. In this way you have to complete this type of problem. Okay, I think this problem also we have discussed. Other problem you just check from the schema of a book, that abstract and linear algebra, you will find there are some theorem. Okay, this type of problem. Okay, your home task is this one. Okay, you try, this is homework 1. And this also homework 2. Okay, I am stopping this class. Next class we will discuss the polynomial. Okay, bye for the day.